Hey everybody, Mr. Grove here. We're going to work a quick roller coaster problem, and so this is a conservation of energy. And so if we have our roller coaster set up as such, and we know the positions of point A, 45 meters, but our velocity is 0 because we haven't started. And then we go down to B where our height is 5 meters off the ground. We want to know what is the velocity. And if we work our way back up to C, we want to know what is the height. Okay, at C, and then we do the same with D. So the way this would set up is we've got a law of conservation of energy. We're going to assume all energy is conserved, so no energy is lost due to friction or anything else for that matter. And so that means our total energy, which would be kinetic and gravitational potential at point A, would be equal to the total at point B. And so our kinetic energy formula we know is 1/2 mv squared. Gravitational potential energy formula is mgh. And so as you see, we don't have a mass, but each one of these components has mass to that. So therefore those masses can drop out. Okay, and that would give us this formula now after we've canceled the mass out. And we know that the initial velocity of A is 0. So that's where this 0 comes from, plus 9.8 times 45 meters equals 1/2 v squared plus gravity times our height. Well, our gravity is 9.8, and then our height is 5 meters at point B. So that only leaves us v to solve for, and so once we crunch the math on that, we come up with 28 meters per second. So then on to find part C, we can say the energy at A is equal to the energy at C as well, because we're not losing, it's all conserved. So our same scenario, so we can cancel out our masses, and we know our initial velocity is 0. Okay, so now that can drop out. So we have 9.8 times 45, that was our mgh, or our gravity times height for part A, equals 1/2 v squared, because for C we know the v is 19.8 meters per second, and then that's squared because of the formula, plus gravity times height. So if we do the math on that, we will come up with a height at point C of 25 meters. The velocity at point B was 28 meters per second. If we work the problem for D, we should come up with a height of 15 meters. Okay, so you can try that one to see if you get 15 meters for part D. And that's how you do the roller coaster problem. So we just kind of set the total amounts of energy equal to each other. The masses conveniently drop out. And then we should have one piece of the puzzle. We're solving for the other piece and crunch the numbers, and that's what we got. So hope that was helpful, and we'll catch you later.